So today we are going to learn new chapter, which is the congruency, enlargement, and combined transformations. This is chapter 5. Yeah, we are reaching half of the book already. Okay, in this chapter 5 over here, there are 4 things that we are going to learn. Okay, we look at the next slide. The first one is the congruency. This one we are going to learn today. Okay, the congruency over here. Okay, hold on. Let me choose the color first. Okay. So before we enter into this, we look at the subtopic that we are going to learn one by one. There will be 4 subtopics. The first one is congruency. The second one is enlargement. So this one we are going to learn on how to find the scale factor and also the area of the image. Okay, the third one is a combined transformation. Over here, we are going to have, for example, there will be a combined transformation of translation, and then maybe there will be a rotation, or maybe there will be a reflection. So it will be combined transformation, and then you have to identify the image. Okay, and the last one is the tessellation. Okay, it is the pattern of recurring shapes that will fill a plane without leaving any empty spaces. Okay, so we go ahead with the what do you call it? The toko, the historian of this chapter. So this one is the historian, the Johannes Kepler, 1571 to 1630. He was a German mathematician and astronomer who had documented the study of tessellation in 1619. So he used the concept of tessellation to explore and explain the structure of snowflakes. So you can see the snowflakes on the right and the picture of that. There are a lot of snowflakes. I'm not sure whether you know all of the snowflakes over here, or we can just identify a few only. For me, I just know a few only, so I also don't know there are so many kinds of snowflakes. Okay, looks very pretty, right? Okay, let's move on. So here we are going to differentiate between congruent and non-congruent shapes. So you observe all the diagram over here. We have 3 diagrams. Okay, they ask you what is your observation regarding the size and shape of each pair of objects shown. So for the first one here, what do you think of the size? How come I cannot write? What do you think of the size?
They are both the same.
Yes, the size is the same, right? Because the length and width are having the same size. What about the shape? The shape is actually the same, and then you look at the pattern inside.
Also the same.
Also the same, right? So we move on to the next picture over here. This is the KL Twin Towers. Okay, so we can see they are also having the same shape and size. Okay, and then the last one over here, the front and rear tires of a car. So this is the front tire. This is the rear tire. Rear means the one at the back. So they are also the same, right? Okay, now we look at the meanings of congruent. So the pairs of objects in the diagrams above have the same size and shape, regardless of their position and arrangement. So we are not going to look at the position and arrangement. Just that when you see the size and the shape are the same, meaning that pairs of objects are congruent. Okay, so we move on to the next one. I wonder why I cannot write when I'm presenting. I can write now. Okay, so let's go on here. The results of mind mobilization. So I didn't go through the mind mobilization. You can look at your book. I just go directly to the conclusion. So it shows that 2 congruent polygons have the same measurement for the corresponding sides and angle. Meaning that over here, if you have polygons that are congruent, they will have same measurement of the corresponding sides and angles. Okay, for example, in the picture over here, we have 2, what do you call this? Trapezium, right? And then these trapezium are actually congruent. So just that this one, the second one, it is rotated to the left already, maybe around 90 degrees. Okay, so actually these 2 trapezium are congruent. Okay, we are going to identify one by one over here. This is quadrilateral A, B, C, D. this is quadrilateral PQRS. Okay, or it also can be a trapezium. It looks like a trapezium, okay, from my side over here, but then because of the angle, they didn't show that it is 90 degrees, so we just mentioned it is a quadrilateral first. Okay, now we look at the length of the corresponding side. You have to, this part is very important. You have to mention the corresponding side carefully. For example, this AB, the longer side over here, it is the same as this length. So when you say AB, they are the same as which one? You cannot mention it as the opposite later. For example, this one is QR. We don't say AB is equal to QR. That will be wrong already because you follow from here, left to the right. The direction is very important. Okay, so AB is actually equal to RQ. So we don't say QR, AB equal to RQ. So we go through one by one. So this is the first one. Now we look at the second one, the BC. BC going this way. So you need to identify BC is equal to which one? So just now, the AB is equal to RQ this way. So we look at BC. BC is equal to, can you identify it? Can you identify or not? If it's, yes, correct. If it is very hard for you to identify, you can draw a new quadrilateral by rotate it back. So if I rotate it back, it will look something like this. You see, so I rotate it this way, meaning that this is PS. This will be R, this will be Q, and then all the angle. So we can compare straight away already. Just now, AB is equal to RQ. We compare these two easier right now. If it's very hard for you to see, to compare this one. Okay, so we compare with the third one right now. Now, BC, just now, I think Ayman, right? Or who mentioned that the answer is equal to QP. Yes, it is the same as QP, this part here. Okay, so we continue with CD. CD, it goes this way. So it means it is equal to PS. It goes this way. And the last one, AD. So AD is from down to the, from the bottom to the top. So it is equal to RS. Are you okay, class?
Yes.
Yes.
Yes,
Okay, now yeah, thank you. So we look at the size of the corresponding angle, the second part over here. So angle BAD, you look at the figure, it is this one, meaning that it is the same as this angle. So the name for this angle is angle QRS. Okay, so we have this one. And then make sure you follow the sequence. You can write down SRQ, but we always write down by following the alphabetical order. So it's supposed to be QRS. Okay, we look at the second one, angle ABC. This is the one, angle ABC. So it will be the same as this angle. The name of this angle, you see, you follow from A, B to the top right now here. So to mention about the name for this angle, it will be RQP. You follow exactly. That's why we have the answer at the bottom here, like this. Okay, we look at the next angle, angle BCD. BCD, this is the one in orange. So same thing, when you move to the right, you are going to mention QPS. Okay, and the last one is angle ADC. So ADC, meaning that you start from the corner over here. So move to this corner, RSP. So we have all of the angle given in this way. Okay, so we move on to the example now. Okay. Example 1 here, they ask you to determine whether each pair of the following shapes are congruent or not. So we have A, B, C, D. Okay, in the beginning right now, you will have to determine slowly one by one, but later on when it comes to the later part, when you know how to find out already, so you don't have to go through one by one anymore. Okay, so I'll still have to show you the example one by one. So for example, the first one, A here. Okay, we need to determine whether the shapes are congruent or not. So for this one, A, B, C, P, Q, R. To determine whether they are congruent or not, the two things that we need to find out is their corresponding sides and angles. These two. So first we look at the side. Side we have AB. So you refer to this diagram over here. The AB actually refer to PR, right? So the measurement is the same, okay? Then we look at the other side. AC is 12 centimeter. So AC correspond to PQ, which is also 12. So nothing wrong. They are the same. Now we look at the third one, the third side here. BC. BC, there's no measurement. So you are going to find out using the Pythagoras Theorem to determine whether it is the same as RQ, which is 13. So actually from the Pythagoras Theorem, we also know already if this is a 5, this is a 12, actually the BC is equal to 5 squared plus 12 squared. So the answer will be 13. 13. Why got line over there? 5 squared, so this is 13 centimeter. Therefore, all the length for the triangles, the corresponding sides are the same. Now, after finding the side, we have to determine whether the angles are the same or not. So, for the first angle that we have over here, this is 90 degrees, so they are the same. Okay, and then move to the right. This one is 22.6 degrees, so they are the same. This one also 22.6. So the last thing that we have to find out is this angle over here. The name of the angle is angle PRQ. Okay, can you tell me how to get angle PRQ? If you still remember.
180 minus the other two.
Okay, you can do like that, but then I told you before already, right? If it involves right angle triangle, you don't have to go through the steps one by one. 180 minus 90 minus 22.6. Directly, you can use 90, this one, minus 22.6. You can get the answer at the same value, 22.6. Okay, so 90 minus 22.6 is equal to 67.4 degree. Okay, 67.4 degree that we have over here, and you need to check whether the corresponding angle of the previous shapes is the same or not. So you look at this one. Yes, they are the same, right? They are the same, right? So when they ask you to determine whether they are congruent or not, so you already found out all the sides are the same and all the corresponding angles are the same. So both shapes are
Congruent.
congruent. Yes, correct. Both shapes are congruent. Okay, now we move on to the next question. So same thing, for the next 3 questions later on, we are also going to determine whether all the corresponding sides and the angles are the same or not. When you find out they are the same, meaning that they are congruent. If one of it is not the same, meaning that they are not congruent. Okay, we look at the B. So this is the example. I think I don't want to display it. I just make it bigger for you. Okay, so we need to identify the side one by one. So we are at AB just now. AB is equal to PU. So to determine whether they are the same over here, you need to find out the length of ST. Okay, so just now ST, I tell you that they are the same because of the sign, the double sign, the double line here, meaning that the ST over here is 3, okay, hold on, 3 centimeter. So when you find out PU is equal to 4 plus 3. 4 plus 3 is equal to 7 centimeter. So over here, PU is not the same as AB, right? PU is not the same as AB. So one of it is not the same already, so for sure they are not congruent. But then you also can find out the other side that we have over here. For example, the length of, which one? Let me see. DC. Okay, if you see DC here, this line here, find out the corresponding side of DC. Which one is the corresponding side of DC? RS? It's not RAC. RQ is the corresponding side. So in this diagram over here, the RQ is given as 4, but then you don't have the length of DC right here. So to determine the DC, we are going to use at to minus 3. What is at minus 3?
5.
Yes, it is 5 centimeters. So is it the same as the RQ over here? All right. Therefore, these two diagrams are not congruent. That is how we find out lah. Because you already find out the length is not the same. So in all the angles is 90 degrees, we cannot determine anything. So over here, we only can determine the sides. Okay. So we move on to the next question, C. Okay, this is C here. So same thing, we are going to determine the side and the angle. So first, we look at the side first. A, B, C, D. This is P, Q, R, S. So let us look at the comparison first. AB is equal to QP, 9 centimeter. So they are the same, nothing wrong. Then the next one, AD is equal to QR, 7 centimeter. They are the same also. So this one now, DC is 8 centimeter. It is the same as RS, 8 centimeter. Okay, next one that we have to find is this one, BC. So BC, how much is it? BC is the same as this one, right? So it is 8. It is 8. Okay, and then we look at PS. PS, this indicate they are the same, so it is also 8. Okay, meaning that all the sides are the same already. Now we have to determine whether all the angles are equal or not. So find out one by one also. This one, 90 degree, yes, they are the same. The next one here, this is 83, this one, so also the same. Then when it comes to this one, 90 degree, is it 90 degree? We need to check. So you can either check this angle over here, or you just need to check whether this angle is 90 degree or not. So for example, I'm going to check this angle. The name of this angle is equal to angle ADC. So to find out angle ADC, this is a quadrilateral, right? Quadrilateral, the total angle of the quadrilateral is equal to 360 degree. So you just need to deduct the 90 degree, and then the 83 degree, and also another 90 degree. So 360 minus 180, 180 remain. 180 minus 83, the answer is equal to 97 degree, right? So this is 97 degree. Then you just need to compare the 97 with this 97. So they are the same, right? Okay,
Yes.
so all the length, okay, all the side, not the length, all the side and the angle are the same for the corresponding side and angle. So meaning that this diagram over here, that two are congruent. Okay, so we look at the next one, this one. Okay, same thing over here. We need to identify whether they are congruent or not. Okay, so first we are going to identify the side. Okay, we have diagram A, B, C here, and then we have P, Q, R on the right. So we are going to find out the side first. You see the side given for AC is equal to 8. They are the same. So this is 8. Whereas the side for PR over here, also the same as PQ, which is also 8. The only thing that we can't find out is over here. Okay. So what you do is you are going to determine the angle right now. Angle, if this is 70, they have an isosceles triangle, so this will be 70. Okay. So 70 plus 70, the angle over here will be 70 plus 70 is 140, right? 180 minus 140, that angle will be equal to 40. Okay, so the corresponding angle for angle ACB, the corresponding angle is which angle? Angle?
RPQ.
Yes, very good. The name for it, this angle is angle RPQ. Are they the same? 40 and 50 Not the same, right? So when they are not the same, either one, the side or the angle is not the same, meaning that this diagram over here is not congruent. Are you okay, class?
Yes.
Okay, madam.
So you just say both shapes are not congruent. Okay, I have a question for you again. Before I continue with the next one, how to determine whether the shapes or the diagram given are congruent or not? Anyone can answer me? How to determine whether a shape, two shapes given are congruent or not? How to determine whether both shapes are congruent or not?
The sides and the corresponding sides and the corresponding angle must be the same.
Yes, perfect. Corresponding sides and the corresponding angles must be the same. Okay, remember this, huh? So we move on to the next. Okay, next slide, this one. What are the characteristics of triangle congruency? So you look at the conversation given. Two congruent triangles have equal corresponding sides and angles. And then can we say that two triangles are congruent if we compare only part of the corresponding sides and angle? Can or not? What do you think?
No.
Yeah, no. If you just compare only part of the corresponding sides and angle, you won't be able to say that they are congruent because there will be proof later on. We are going to go through later on. There will be proof showing that they are not congruent. Okay, let's see. So this is called the property of triangle congruency, or sometimes in the book they will tell you this is called the triangle congruence rule. I write down here, let you see. Triangle congruence rule. Okay, so we have 6 types of properties of triangle congruency over here. You have to familiar with it because some of the later cannot come first. I'll tell you what is it later on. For example, you learn probability already, right? If I say in a box there are 2 letters, letter S and letter A. So you are going to draw the letter one by one from the box for 3 times. Okay, for 3 times, and then there will be a replacement, meaning that you draw and then you replace it. So they ask you to list the possible outcome. If I ask you to list the possible outcome, can you tell me what are the possible outcome to draw the letter 3 times? So the first one, I show it to you. It is S, S, S. I draw 3 times. Okay, remember each of that time, I return the letter into the box. I only have 1 letter S, 1 letter A. Can you tell me what is the next outcome? Anyone?
I don't understand, madam.
Don't understand. Okay, I'll repeat my question. In a box, I have 2 letters. That is letter S, letter A. Now, I want you to draw the letter from the box 3 times with replacement. Hopefully you still remember the probability. With replacement meaning that after you draw letter S, you put it back. You draw 1 times again. Then you put it back. I said you draw 3 times, right? So you draw again. So we will have the outcome like S, S, S. Okay? And the possibility of the outcome for the next one could be S, S, A. Because we draw the third one with letter A. And then it can be, you draw S first, continue by A, and then you draw S. This is the third one. And then it can be, you draw A first, and then you draw the S later on, and the S later on. Any other outcome? Any other?
AAS.
AAS, correct? Oh, sorry. What happened? This is a slide. I escaped from it now. Okay. Okay, so you have AAS. What else? We will have add actually. You see we have the first one, SSA. Correct? How many A?
3.
Yes, correct. A. Any more?
SAA.
SAA. Yes, correct. SAA. Any other?
ASA.
Yes, correct. ASA. Is there any repetition or not?
No.
No, huh? I think that's all right. Okay, so these are the possible outcomes. Why I asked you to list down all of this, because later on I want you to see which one is not included in this triangle congruence rule. Okay, so you can see the first triangle congruence rule is SSS. We have to go through the details one by one. First one, from this side, SSS means side. So it means the length of the corresponding sides are equal. So you can look at the diagram on the right over here. All the sides are equal. This one equal to this one equal to this, and this one. Okay, so they told you AC equal to PR, this one. And then AB equal to PQ, this one. And then BC equal to QR, this one. Okay, so now we look at the next property, that is the SAS, side angle side. You get used to it. Once you get used to it, you won't be mistakenly write down the sequence. Okay, so we look at the first property here. Two corresponding sides are equal in length, and the sides of the corresponding subtended angle between the two sides are equal. It means like this, side angle side. After the side, it follows by angle. After that, it follows by another side. Okay, so you can see given AC equal to PR, this one equal to PR. And then BAC equal to QPR. So BAC is the angle over here, is equal to angle QPR. AB equal to PQ. So this one equal to PQ. Okay, so these two are SSS and SAS. Okay, we look at the next one. Next one is ASA. ASA, angle, side angle. So two corresponding angles are equal, and the length of the corresponding side between the two angles. This one, the length between these two angles are equal. So they give you angle BAC, this one, is equal to angle QPR, this one. Okay, and then AC equal to PR, and angle ACB, this one, equal to this one. So it is this is angle, side, angle. Same thing, angle, side, angle. Oh, remember this one. Okay, next, it is angle, side. Angle, side is like this, angle, side. Okay, so two corresponding angles are equal, and the length of one of the corresponding side which does not lie between the two angles are equal. That side must not lie between the two angles. So not only the diagram like this, if your angle is this part, angle, then you are going to take the side over here. So it can be many ways. You also can take the angle from C here, angle, then you are going to look at this side, angle, side. Okay, so remember this one, angle, side, angle, side. Okay, the next one will be angle. So this one is easy. The one with three sides and the one with three angles. So you just have to determine all the three corresponding angles are equal. So this one, angle A must be equal to angle P. Angle C must be equal to angle R. Angle B here equal to angle Q. That's all. Okay, so the next one is side angle. Okay, so side angle, this one, two corresponding sides are equal in length, and one of the corresponding side which is not subtended between the two sides are equal. So that angles cannot be subtended between that two sides, which means if you have side angle, your angle cannot be here. That's not correct. Okay, if like this, it will be side, angle, side already. So this is not side, angle, side. This is side, side, angle. So we can go this way. You also can go this way. To get the side, side angle, it can be like this: side, side, angle. Okay, there are many ways. You just remember it follows the sequence side, side, angle. So the area of the pair of triangles must be equal for this situation. It's a bit different for this one. The area must be equal, only then you can say that they are congruent. Okay, with the condition of the corresponding side AC equal to PR, AB equal to PQ, and angle ACB, this one, equal to angle PRQ. Okay, we look at how to apply this. So first, the second example here. Okay, determine whether each pair of the following triangles satisfy the properties of a triangle congruency. So this is the one that we go through just now, the 6 properties of triangle congruency. Justify your answer. So we look at the first diagram here, the A. So we have side, angle, and then this one another side. Okay, so this one falls under which one? Do you still remember? I cannot say side, angle, side now because you have to go through side by side. So the side come first. Side come first, and then this one. So it is?
Side, side, angle.
Yes, very good. Side, side, angle. Okay, so we compared all the corresponding sides and the angle with the other diagram on the right. So first one, this is 6. This is also 6. This is 10. This is also 10. This is 25. This is also 25. Okay, they are all the same, right? But then the triangle doesn't look the same. So it means over here, the area is also different. So are they congruent or not?
No.
No, right? Although they satisfy the property, they satisfy the property of triangle congruency, the side angle, but then they are not congruent. So you look at the solution given here, down here. No, okay. Although both triangles have 2 corresponding side and 1 corresponding angle of the same measurement, the remaining side and angle are different in measurement. So the areas are different. Okay, so you got to remember this, the remaining side and angles are different in measurement, and then the areas are different. Why? Because the angle over here, you see, we have 25 already, they are the same. But then the next one, which is in between 6 and 10, this angle, in between 6 and 10, this angle, they are different. Same with this angle over here, they are different. Okay, and also the area is not the same. So now we look at B, diagram B here. Okay, this triangle, we have all the same angle, 36.9 for this one, and then 53.1, this one, a 90 degree here, this one. All the angles are the same. But then if you refer to the side, this is 4, this is 8, this is 10, this is 5, and this is 6, this is 3. They have all the corresponding angle, but then they don't have all the corresponding sides, right? So meaning that these two doesn't satisfy the properties of triangle congruency because the corresponding sides are not the same. Therefore, the area is also different. One have bigger area, one have small area. Okay, so you look at the answer for this one. No, although both triangles have 3 corresponding angles of the same measurement, all the corresponding sides are different in measurement and the areas are different. So look at the smart tips. This one is important. Side, side, angle. This one, side, side, angle. And angle, angle, angle. This one, angle, angle, angle. Cannot be used to determine 2 triangles are congruent except the areas of the triangle are the same. So you got to remember for these two, side, side, angle, and angle, angle, angle cannot be used unless the area of the triangles are the same. Are you okay, class?
Yes.
Okay.
Okay. I'm reading all the while now. I'm going to ask you to read right now. So who are available? We have 41 over here. Let's see. Azlina is here already finally. Azlina, can you read example 3 right now? Azlina?
The diagram below shows two congruent triangles. It is given that the triangle congruence rule used to determine both triangles are congruent is angle side angle. Complete the table below with the other characteristics involving angle side angles.
Okay, thank you. So you look at these two congruent triangles over here. We need to find out the angle that is using side angle. Okay, this one. So they ask you to complete the table below with the other characteristic involving angle side angle. Okay, so if you look at the angle, it's already given for the first one. If I'm going to use angle side angle, meaning that I can use this part, angle side angle. You also can use the other way, angle side angle. But because I've chosen the first one already, so I just show you the first one, angle side angle. So for the angle of triangle, this one, angle ACB equals to angle DFE, this one. You got to see carefully, it starts from this one, meaning that it is CAB. This one is FDE. It goes this way. So make sure your sequence of your letter is correct later on. So the side will be side AC or CA. This one is up to you. Okay, so which number you want to use? Which letter you want to use? Because I say already, you have to follow the alphabetical order usually, right? So we just use AC, okay? AC. Are you okay?
Yes.
Okay. So AC, can you let me know AC is equal to which one from here on the right, the second diagram?
DF.
AC is equal to which one?
DF.
Yes, very good. This one is equal to this. So DF. So just now I said angle, side angle. So this part also angle, side angle. Okay. The third angle over here. What is the name of this angle? This one. Angle?
Angle ABC, right?
It's angle BAC. We cannot say ABC, A must be the, yes, correct. Angle BAC is equal to, what is the name?
Angle
Which one first?
EDF.
Yes, correct. You follow the alphabetical order. Angle DE, DF. So we got the first one already, Now we are going to get the other one. Look at this diagram here, the table. Angle ACB equal to angle DFE. So they gave you this one, angle ACB equal to angle, I think I write off everything. Angle ACB, this one is equal to angle DFE. One more time, they are the same. So just now we go this way, angle side angle. So I go the opposite way right now. Okay, the opposite way will be angle side angle. So same thing over here, angle side angle. Okay, you look at the side. What is the name for the first side? What is the name? Correct, BC. BC is equal to what on the second diagram?
EF.
Yes, EF, correct. Now we refer to the angle, this one. Okay, what is the name of that angle?
ABC.
Very good, angle ABC. What about the corresponding angle on the right? Which one is the same? This one, right?
Yes.
Okay, what is the name of the angle? Yes, angle
DEF.
EF, correct. Are you okay, class? Any question?
No question.
Yes.
Sometimes when the diagram seems very confusing, what you can do is you can redraw it follow the same diagram as the first one. You redraw, but then meaning that you rotate, then you have to make sure you label it properly after you rotate. So for example, if I rotate this one, the D, this one will be F, this one will be E. Then you compare one by one. So AC is equal to DF. So for example, this one, AC equal to DF. Then it will be easier for you to compare. If you have no problem comparing these two, then you just go ahead. You don't have to redraw. Okay? So we move on to the next example here, example 4. Okay, in this example, actually this one is not given. I cut it off first. Now let ask somebody to read this. Adam. Okay, Adam is here. Adam, can you help to read?
Yes, madam.
Yeah.
The diagram below shows a triangle EFG. It is given that another triangle KLM has the same shape and size with triangle EFG. State the triangle congruence rule used to determine if both triangles are congruent.
Okay, thank you very much. Nice voice, right? Like Azina also. So it is given that another triangle KLM has the same shape and size. So that's why I have this diagram just now. So I redraw. KLM have the same shape and size with triangle EFG, the first one. Set the triangle congruence rule to use to determine if both triangles are congruent. So the triangles congruence rule is the one that you learned earlier. That is the SSS, SSA, and so on. So you have to determine is under which one. Okay, but then sometimes the given diagram, this one, this diagram given over here, for example, this question given, they won't arrange everything nicely for you. Sometimes they will jump. The last one come first, and then the second one at the last. So you can't determine directly unless it is the corresponding side that is the same. For example, the first question here, everything involved is about angle. Oh, so no, this one is not about angle only. Unless it is all angle, all sides, then you can say it is AAA or it is SSS. So for the question that we have right now, you have to identify one by one. So for the first one, EGF. EGF, that is the angle, is equal to KML. So KML, this is the angle. Okay, that's the first one. Next, EFG. EFG, this angle, is equal to angle KLM, this angle. And the last one, EF is equal to KL. This line is equal to KL. So from here, you already can guess already, it is actually equal to angle, angle, side. Okay, angle, angle, side. I write down the answer first. Now, I have a question for you. Can we say it is side, angle, angle? Can or not?
No.
Why no?
Mesti ketat.
Why no? Because it is not in the
Ikut urutan.
triangle congruence rule. Let's see. Do we have SSA? This one. Sorry. Okay. SSA, we go through the triangles congruent. Is there, sorry, SSA. Just now it's not SSA. SAA. SAA. Okay, let's see. Any SAA? Any SAA? Any SAA? No, right? So it's not in the 6 triangle congruency properties over there. So we cannot say that it is SSA. So you have, no matter how, you have to use AAS. Okay, now we continue with B. Yeah, this one keeps moving. Okay, so I just move it down here a bit. Okay, we look at the B. This one I need to rub off already. I cut it. Okay, use this one. This one I rub off. It's not clear. Give me some time to adjust this. I see whether I can do, also cannot. Okay, never mind. We just use different color then. Okay, I use blue, not blue, red. Okay, B, look at question B right now. EG equal to KM. So EG is this one, equal to KM. FG equal to LM. FG equal to LM. This one actually we can identify straight away. EF equal to KL, this one. So this answer is easy, right? What is the answer for this one?
SSS.
Correct, SSS. This one won't be wrong, won't go wrong because it's already very clearly showing that they are comparing the corresponding side. Okay, now, so B, no problem. We go on to C. Okay, C, the first one is F. I write off this one first. Okay, F, we have EF equal to KL. So EF equal to KL. The next one, angle EFG, this one, equal to angle LKM, this one. And then the EG equal to KM. So EG is this one, equal to KM. So the M write down correctly. FEG. Oh, my angle is wrong, sorry. FEG is not this one. FEG is here, the angle E. Okay, so can you identify this is under which triangles congruent rule?
SAS.
Yes, correct. That's very clear. SAS. There is identification. So do you have problem with identifying?
No.
Right. Okay, but then okay, thank you. But there is one thing that you have to remember. You look at the info bulletin on the right over here. Right angled hypotenuse side, RHS, is also a special congruence property for right angled triangle. If the hypotenuse and one of the corresponding non-hypotenuse side of two right angled triangles are equal in length, then the two triangles are congruent. Okay, this means only involve the right angled triangle. Okay, if the hypotenuse and another one of the side, the non-hypotenuse side, so it can be this one with this, or it can be this one with this. Okay, so follow this. Okay, the congruence property is based on side, angle, side. Okay, you see again, you see this, then the two triangles are congruent. This one only applied for right angle triangle. If one of the side and the other non-hypotenuse side with one angle, okay, which means it is side, side, angle. Or it can be from the right, side, side, angle. So they are congruent based on the congruence property of side, side, angle. Are you okay? The side, side angle? The side, side angle has the most problem actually, this one, the side, side angle. Like just now we go through one of the example whereby if the area is not the same, if the area is not equal, then they are not the same. You cannot follow the side, side angles rule unless the area must be the same. So from this info bulletin, we also found out that if it also apply for a right angled triangle. If the hypotenuse side is the same and the other non-hypotenuse side is the same, meaning that they are congruent. Okay, this is for side, side angle. Remember, the side, side angle. Okay, so we move on. We're almost at the end already. Solve problem. We have two problem solving over here. Okay, somebody help me to read again. Remove Adam. No. Imran. Okay, Imran. Can you help me to read?
Yes, madam.
Yeah, you read it.
The diagram on the right shows an isosceles triangle PQR where PR equal to QR. A and B are the midpoints of the sides PR and QR respectively. Show that triangles PBR and QAR are congruent.
Okay, thank you. So if you look at diagram 5, I make it bigger. I know your screen will be small when I show like this. Okay, we have one triangle over here only, whereby PR equal to QR. So you can look at the length over here, the PR equal to QR. A and B, this point over here are the midpoint of the side. Okay, and then you were asked to show that the triangles PBR and QAR are congruent. So where is PBR, where is QAR? Then you have to draw the line. This is PBR, this one, this triangle. Huh? And QAR, I use another color. So this is QAR, this triangle. Okay. So they ask you to show that triangles PBR and QAR are congruent. From your eyes, if you look like that, are they congruent or not first? Congruent or not?
Yes.
Yes, right. Yeah. See directly, it is congruent actually. But then we need to show that they are congruent. So how to show that? Actually, you just need to show based on the 6 rules of the properties congruent rule. Okay, the rules over there, the SSS and so on. So we find out one by one. So for example, P2, not the PR, let me see. Okay, we use this side here. I redraw the triangle so that it's easier for you. This one is triangle PBR. And then we have another one, something like this. Okay, so this one is QAR. Okay, so we need to compare the length, the side, and the angle. It's up to you to choose. So from here, clearly seen already, this length, the longest one, they are the same, right? So we just write down PR is equal to, which one? Are we going to say RQ?
QR.
You have to follow QR. You follow the direction. If I said PR, then you have to follow the direction. It's QR. PR equal to QR. The first side is already the same. Now we look at the angle also. The angle is the same, right?
Yes.
Okay. What is the name of the first angle? This one.
Angle.
Yes, very good. Angle PRB. Angle PRB is equal to angle what?
QRA.
Yes, angle QRA. Okay, so the angle is already done. Next, we move on to the side over here, this one. They are the same, right? So what is the name of the first side?
BR.
Very good. BR. BR is equal to which side?
AR.
Yes, you cannot say RA, AR. So this is side, angle, side, right? The triangles PBR, this triangle PBR and also triangle QAR, they satisfy the property of side, angle, side. Are you okay? Side, angle, side. Therefore, these two triangles are congruent. Can or not? Can? So besides using side, angle, side, you also can just follow any of the triangles rule that we have learned earlier, the 6 triangles property. So besides that one, you can say side. I use different color so that you can see. Just this side. You also can use angle, side over here. Or you can use side, side, side. Or you can use angle, angle, angle. But then when it comes to the angle, you got to remember you have to make sure the area is the same. So when you look from here, the area is actually the same already. So angle, angle can also be applied. Okay, so it's up to you which one you want to use out of these 6. Okay, or not, class?
Okay.
Yeah. So we move on to the next. Yeah. This one I did it first. Okay, look at the question, example 6. Now somebody help me to read. Nurul Izzah, you're there, right? Nurul Izzah, you help me to read this. Example. Nuri Iza, are you there?
Sleeping.
Okay. Gary, your turn then. You help me to read.
Example 6.
Yes.
Siva prepared 2 pieces of congruent trapezium shaped cards as shown in the diagram below. Each card is painted with half of a logo. Next, madam.
Yeah, finish it.
Siva put the 2 pieces of card together to form a pentagon with a complete logo. If the perimeter of the pentagon is 20 centimeters, calculate the area in cm square of the pentagon.
Okay, thank you very much. So you see, she has two trapezium, the congruent trapezium in the diagram like this. You're given the two congruent trapezium. If congruent meaning that CD 20 centimeter, the SR over here will also be 20 centimeter. RQ 13, so the AD will also be 13 centimeter. Okay. Siva put the two pieces of card together to form a pentagon. So this is the pentagon. You can see 1, 2, 3, 4, 5, 5 sides. Is it a regular pentagon or irregular pentagon?
Irregular.
Yeah, irregular. Thank you. If regular, then all the sides will be the same. So if the perimeter of the pentagon means that when you add up, the perimeter is equal to 90 centimeter. They ask you to calculate the area of the pentagon. So before we find the area of the pentagon, you will have to find the side of the pentagon. We have all the 4 sides already except CS. So the first thing is we need to get the length of CS. That is the combination of CB and also SP, so that we can get the area. It's very important to get the area. So CS over here, you have to use 90 minus 20 minus 13 minus 13 minus 20. Okay, so 90 minus 40 is 50 remain. 50 minus 26, so the answer is 24 centimeter, which means BC and CP, each of it is 12 centimeter. Okay, so now we are going to calculate the area of the pentagon. So meaning that we know this is 12, this is a 12. Okay, from the pentagon that I have, I paste here first. Okay, this one, we go back to this. So this pentagon here. Okay, this one is 12. I repeat again. 13, not much use actually, but then we can find the total AB. So AB, do you know how much is the length of AB? You know or not? Don't know, right? So what you do is, because this is 90 degree, we are going to form a rectangle. Okay, so if this is 20, this part also 20. We just need to look for this length over here. So we assume the length is X. Okay, this side will be following this is 12. Okay, so to get the value of X, we use the Pythagoras Theorem, right? It will be the square root of 13 squared minus 12 squared. So 169 minus 144, the answer is equal to 25. 25 is equal to 5 centimeter. Okay, so the X is 5 centimeter. Now, can we get the area? Can, right? We are going to calculate following the area to find the trapezium. So the formula to get the area for a trapezium is 1/2 times A plus B, or we use this one over here, this diagram. So the X is 5, we know already. The length will be A is 20 plus the B is 25 times with the height is 12. Are you okay? That is the formula to get the area of the trapezium. Can, right? So how many trapezium do we have?
2.
Correct. Multiply by 2. Okay, after that, you just simplify it. So 2 cancel with the 2 here. Okay, 20 plus 25 is equal to 45. So 45 times 12, you get your calculator. 45 times 12, how much is it?
540.
Okay, thank you. 540 centimeter squared. Okay, do you have any question, class?
No question.
No question so far. Okay, there is another method that is shown in your textbook. This is the one. So you also can use this method whereby they find they divide lah. They get the rectangle of CDRS. So you can see CDRS, the CDRS, the big rectangle. They get this area first, which is 20 multiplied by 24. Sorry, this one. After that, they get the area of the triangle DRA. This is DRA here, which is 1/2 times 24 times the height over here is 5. Okay, so the area of the pentagon will be the total plus this area. So it's 540. Okay, right? So you can see down here the slide already. That's the happy hour for today. Okay. Jot this down. This is the self-practice that I want you to do. 5.1a, 5.1b, 5.1c. All of it, you don't have to copy question unless you want. Maybe you want to copy the diagram. That will be easier for you to show the calculation and so on. So question, no need to copy, except for the diagram for 5.1c. The rest also, because the question have a lot of drawings. So it's up to you. If you are hardworking enough, you copy. Okay, so we summarize everything that we learned today from the beginning. Okay, so today you learn about congruency. Congruent polygon have the same measurement of the corresponding sides and angles. So you remember this. Congruent polygon must have the same measurement of corresponding sides and angles, these two. Okay, after that, we also learn the triangles congruency rule. That is the SSS, SAS, ASA, AAS, AAA, and SSA. Okay, make use of this triangle congruency rule. Okay, so that's all for our lesson today. In the next lesson, I'm going to discuss the self-practice 5.1a to 5.1c with you. So during that time, same thing, you are going to get ready your exercise book and then we are going to check the answer together. But you can check in advance first to find out, to determine whether your answer is correct or not. Okay, so that's all for today. Do you have any question, class?
No question.
No question, good. So we stop here right now. I'll see you on next week.